everyone. Can you hear me? Is it all good? Okay. I want to apologize in advance because I got cold yesterday. So if I cough or something, I'm really sorry for that. You know, Murphy's Law is validated, so that's good. And there was some brief introduction about the Grab, but because we are in the US, I really would like to give a little bit quick intro, like what it is. Grab is a everyday, everything super app. So if you ever travel to Southeast Asia, you can't miss it. Like you will definitely see Grab, you will, perhaps use Grab. You can do a lot of things with the app. So you can book a ride, you can order food, you can send a package, to your friend. If your friend lives across the town and forgot some of his belongings in your apartment, you just instantly, can send his belongings to him across the town using the app. So me personally, oh, by the way, where is sorry, this one. Yeah. Me personally, I live in Singapore. We are a Singapore company. My team is sitting right here, actually. And I use Grab every day. One of the interesting or sort of unusual use cases, I would say, is payments. You can also pay with Grab. So a lot of these merchants in Southeast Asia, they don't have a terminal. They are not accepting credit card, and I don't carry cash with me usually. So I have this merchant downstairs of my apartment where I just go and scan a little QR code with my Grab wallet and basically pay for my dinner. So you can really do a lot of things with the app in Southeast Asia. And who I am, okay, good, that works. My name is Pavel. I am originally from Czech Republic, and now I live in Singapore. I have 10 plus years experience. I started to work for many years in Foxconn. If you don't know what it is, it's that company that manufactures iPhones. After that, I tried to build my own startup. That basically just resulted in me stop recommending it to people to try. So, yeah, I don't recommend it. Then I joined Tesla as a staff software engineer, and finally I moved to Singapore to work for Grab. Now, during this 10 plus years of working with various technologies, and I have really worked with a lot of different technologies, like, different various kinds of databases, message brokers, orchestration systems, like you name it. There were only few technologies that really fundamentally changed the way I think about building distributed systems. And those few technologies that really changed my mindset, they have a lot of things in common. So first, they are all open source and they have amazing communities, like amazing communities. Second, they just reinvented the wheel. So they went to some part of computer science and from first principles basically introduced much superior paradigms to us engineers to build better, more scalable software. And we can do it with much less effort with these paradigms, usually. Of course, Temporal is one of those technologies, so that's why we are here today. And what are we going to talk about? So a little bit lighter talk. I'm not going to go into code base and explain in detail some sort of implementation trade-offs and challenges. We have basically decided to share with you our journey of where the idea of using Temporal originated in Grab, what was the problem that has driven us to that idea. And for that, we are going to introduce that problem. And you also need to understand why it is really a massive, massive problem. So our problem is in the domain of customer support. And if you imagine customer support, you probably imagine it something like this. So you have a company, your company offers a product or a service that generates value for that company. Now, your users are obviously using the product, run into some issue, need to reach out somewhere to someone to help them to solve their issue. Now, for that, we have some channels like live chats, chatbots, voice calls, things like that. And on the other line, you have a trained professional who is going to help you to solve your problem or solve your issue. It looks simple enough, right? So why are we solving that? Well, the problem is that in Grab, this is not that simple. types of problems. Problem is that in Grab, this is not that simple. So as we already established, the Grab is basically a super app. So we offer many different types of products and services to many different countries. On top of that, not all services are available in all countries. So if you come to Singapore, if you travel, come to Singapore, this set of icons which you will see on the app will be different than if you go to Bali in Indonesia. It'll just be different services. In the same time, we only have one customer support because we are still one company and we need to support everybody across the entire Southeast Asia. So this problem is becoming a little bit bigger because now we basically have sets of issues from different types of services. So food can give us some of the issues, like missing item, something like that. Transport is going to give us different type of issues, etc., etc. Now, there are also additional nuances to this one. Like, for example, some countries support only one language, some countries support multiple languages, etc. And it is still not that simple. In Grab, we not only have one app, we have multiple apps. So the standard Grab app, which you might use if you travel to Southeast Asia, that's the one who order food with or pay with or do whatever you want with it. Second is a Grab driver app. That's for our driving partners. If you book a ride or if you order food, they're using this app to deliver you the service. And lastly, we have a Grab merchant app. That's for merchants to acknowledge and fulfill your orders. What we are really ending up with is an ecosystem that grows in multiple dimensions. So the total number of customer support requests that can potentially come for this sort of ecosystem is somewhat loose permutation of all of these dimensions. And there are not all dimensions on this slide. I didn't even mention segmentations and other things. So the enablers who really help you with it are agents and programmers. So trained professionals and programmers, because every time that you have some problem and you need to get some compensation for it, there has to be code for it. Like someone actually has to code some refund. Someone actually has to provide some code for you to receive your points or top up your wallet or receive some voucher or something. So every time, every resolution requires some sort of execution logic. And as the ecosystem grows in complexity, and it grows very, very quickly, and it's very dynamic, we are getting into the problem that we can't really keep up with the number of possible customer support requests that are coming in this ecosystem. And we need to do something about it. So the first thing, and the natural sort of a naive thing I would guess you can do, you can just try to brute force it. So just let's hire much more people plus the number we already have, and let's just hire much more programmers plus the number of programmers we already have. But it's not ideal, right? It's not practical, and ecosystem is just so dynamic that we cannot that quickly adjust the resources that quickly. So we need better solution, engineering solution, right? So we need to figure out the way how to offload all of these people and simultaneously still provide some good quality customer service. And that really is what brought us in Grab at the idea of building some sort of our automation platform. But what is how would we go around that, right? So we have a complicated ecosystem. How are we going to automate this sort of flow of so many customer support requests? So when we get to the drawing boards, what we really start doing is let's start placing some sort of automation at the place when it makes the most sense to us. And because our customer support flow here on sort of a simplified visualization have multiple channels, so the customer support can come from offline channels, online channels. Those are some live chat and voice calls. As offline channels, we have digital forms and chatbots. And So when we start placing it, we are really like thinking that the best way how to do it is to start at that part of the offline channels, because in the live channel you get directly connected to someone live, and the point of automation a little bit like the value of automation a little bit decreases there. So we start basically in this way. There's also a caveat, and that caveat is that sometimes the automation actually needs to be able to fall back to agent to perform some sort of human decision, because not every automatable resolution can be just fully automated. Sometimes human decision is just needed. And at the end of the day, we want to provide resolution to our customer. So when we started to really like designing this sort of system, we started to collecting or clarifying what are the set of requirements we would need from this system. Okay, guys, so if you are still with me, I would like, if you are not sleeping, sorry, I would like you to pay attention to this slide, because this basically is what narrows down our use case to just one thing, and that's temporal. So it's pretty interesting niche. We need the 3 pillars of requirements for our system, that is scalability, performance, and resiliency. When it comes to scalability, we also think about scalability in multiple dimensions, because we have a large ecosystem that's very dynamic and is changing very quickly. So what basically that means is that every possible customer support request needs slightly different resolution path, slightly different set of rules and conditions, maybe slightly different policy, which basically result in us building a lot of different workflows. Not just one, not just you, not just 2, but hundreds and hundreds of workflows. So it's one sort of like a dimension of scalability we are thinking about. The second dimension of scalability, of course, is the computing resources. So the customer support is basically the system which will take a hit if anything goes wrong, because all the volume of unhappy customers coming to the customer support. And we need to make sure that we can run concurrently, simultaneously on the cluster a lot of workflow executions. If one customer has a problem, we run one workflow execution. If 1 million customer has a problem, we run 1 million workflow executions. So it's a very important requirement for us. And lastly, cost efficiency. So at our scale, we are super cost sensitive when it comes to designing and building new systems. So I put there, like, we are ruling out all Redis-based solution, because at this scale of simultaneously running workflows, storing workflow history to Redis, it's going to become very expensive. So we really wanted to avoid that. There are better databases for this use case. And here, when it comes to performance, things are getting even more interesting, because we don't use workflows probably as usually other people use workflows. One of the most interesting use cases for low latency and synchronous workflows are chatbots. I will give you an example as a user experience here. So I have a problem. The problem can be I have a missing item in my order, and it's a legit problem. I take a picture of that. It's not there. I go to chatbot. I'm going to explain my problem to the chatbot, and chatbot take a look at it. There's some classification, some computer vision, and things like that behind that. And what really needs to happen from the user experience point of view is that I type my problem, I place my picture. Okay, chatbot says, I'm taking a look at it. Okay, we are so sorry for this experience. Here is your refund. Is there anything else I can help you with? And that's it. And user cannot just sit there and like wait 1 minute, 2 minutes, loading screen or something like that. Like when he finally gets what he needs, and he's really frustrated because something went wrong and it's not his fault. So we need to be in control of latencies. Sometimes long latencies or long-running workflow are good, but sometimes we want workflow to feel just like HTTP request. We want it to be very short. And this is where it becomes very tricky, because not many actually platforms offer anything like that, anything close to that. And Temporal offers everything we need when it comes to control of the latency. It gives us availability to to model the topology of our own task queues, or have dedicated workers for more important things, shared workers for other things. It gives us local activities, which basically, help us to reduce the jumps in the network, to reduce the latencies. It also gives us ability to choose our persistence layer. If we really care about the latency, we need to choose more, faster, high IOPS persistence layer. And lastly, when it comes to performance, is a control over the SLA. And that basically means that every single customer support request has some sort of SLA attached to it. So we are absolutely responsible to provide resolution under a certain time. So things like timers, durable timers, and sleeps are extremely crucial here, and we want to be under control when it comes to time. So the last pillar, resiliency, as we already established. When there is an outage, Grab support basically is the system that gets a spike. We cannot lose any tickets. We cannot lose any customer data. It's like there is basically no way where customer report their issue and then they are asked to report it again. It just cannot happen. Like the moment you report the issue, we are solving it, we know about it, no matter what happened. As a second thing, basically, durable automation. These workflows, they are communicating with a lot of internal microservices. As you saw in the beginning, the number of products we are basically offering. Can you imagine the number of internal microservices that basically fuel those products? It's a lot of microservices. And every time that there is some resolution path for your system or for your problem, we need to communicate with those internal microservices in order to get context, in order to be able to actually enable you some sort of resolution, etc. And those services can fail at any given time. So we cannot punish our customer for any sort of transient failures in our platform, any sort of rate limiting or networking issues, etc. Lastly, maintenance. So the maintenance is something which becomes very hard if you have hundreds of workflows. And we need to be able to very quickly identify where the problem is, debug it, fix it, ship it, move forward. With this one, Temporal is also giving us amazing, workflow execution history. When if some microservice which is under daily development changes the API contract and breaks our flow, our resolution flow, we can just right that day, maybe in a few hours, fix that problem and ship it to production. If you have a well-designed system, you can do it without customer even noticing that there was a problem. It's only us who noticed. Yeah, so that's a lot of requirements. Honestly, we thought we can do it better, so we tried to do it ourselves first. And we built our own workflow orchestration engine at a time that actually went to production and worked for some time. But the team basically quickly realized that after some time, that simultaneously building workflow orchestration engine and automation platform is just too much, especially when automation platform is the driving force of the value for the business here. So what we did is that we moved to Cadence. We created a cluster for Cadence and MySQL at the time that worked quite well until it didn't. So as we grew, and by the way, at the time we were really inexperienced of how to maintain or how to even deploy a workflow orchestration cluster. So after some time, we started running in issues, latency issues, scalability issues. We're upsizing basically our RDS every few months because we were running out of the IOPS limits, and it was really pain. So we decided to move again. That was the last year. And what we did last year is that we basically created a small team, very targeted team to rebuild the entire workflow orchestration cluster. And we did it with Temporal. Now, when we were deciding what to do here at a time, we really need to, our primary goal was to gain a lot of experience with the Temporal and really gain a lot of experience with how technology works. Because we were worried from our previous experiences with Cadence that if we do not gain that experience, we won't be able to effectively operate in production. So we spent some time We have also decided here to build the temporal cluster on Scylla instead of Cassandra. That was a very good decision in retrospect. It just took a little bit longer time for us to figure out how to do it well. I mean, it took a little bit of time and one painful outage to figure out how to do it well with Scylla. So, but we figured it out eventually. And for this year, it's just like smooth sailing. Like our cluster is handling very good latencies and very good throughput, entire customer support automation with absolutely no problem at all. On this slide, you can see a little bit like our automation platform look like on the right side. The tech stack is Temporal, Scylla, and Go. You are able to build any sort of workflows. You are able to call any sort of internal microservices in Grab ecosystem, conditions, branching, parallel execution, things like that. And you just click button and move it to staging, and then you move it to production. This is actually our original design. This is how it's, this is sort of like a modernized design at the moment. Pretty much an ongoing effort for this automation platform. This platform already also allows signals and queries and much more advanced temporal features than ever before. And allow us basically to scale the number of workflows very, very, very quickly. You know, on the beginning, we were also a little bit worried that like maybe DSL is not the best like a DSL on temporal is not the best approach. But eventually for our use case, when you have a very good specific domain use case, and you build DSL as the domain specific towards your particular use case, it works very well and it works at scale, and there is no performance implication, or not at least any visible performance implication when it comes to running DSL on temporal. So it works very well. Okay, so this was pretty much how we started with temporal. And for the second part of the talk, I want to talk a little bit about how have we evolved with temporal. That's because when we started, we really didn't care or didn't know much about like resiliency, you know, durable execution, things like that. We just needed something that fulfill our requirements and that will enable us to build an automation platform. And that's basically what temporal did at that time. But as we became more experienced with it, which took several years, by the way, this journey is like since 2018 until today. But as we became more experienced with this, we started to seeing that our mindset and our sort of thinking about how to build software is changing. And it gets to the point that nowadays, basically every time we have some like RFC review or brainstorming, we see the workflow, right? I mean, it was already said yesterday, like, but it's really the thing, like, you know, we should put it on workflow, you know, this is not durable enough, you know? So it got to that point that now my coworkers making fun of me every time when we are in meeting and someone is telling that, you know, something doesn't work properly or something is causing production issues. You know, it's always someone pointed at me and saying, you should put it on temporal, you know? So, yeah. It's really much a joy to working with temporal, and it opened all sorts of other possibilities. And it only did it because it actually delivered on promises. Like if it don't deliver on promises, then it wouldn't work that well, right? And we wouldn't feel as joyful. So this year, pretty much, when we established much more bigger trust to temporal cluster and much more better experience with designing and building workflows, we started to thinking like, where else should we go? So our use case original was the DSL use case, but we really wanted to go for code first. Like we really wanted also some long-running code first workflows in some parts of our systems that could pretty much elevate our architecture. So this is how our architecture pretty much looked like at the time when we first like shipped automation platform. And you notice that in this architecture, we are resilient and sort of like a durable at that part where temporal is orchestrating it. But if anything goes wrong before that, then basically it doesn't matter, we are still down. So we had to change that, right? And there is so many things that can go wrong here. Like, it's really not that good. If the ticketing system goes down here, that's basically where all your tickets or your customer support requests goes. What is gonna happen is that you are not able to run any automations. And that's because the ticket proxy, which is proxying all the tickets, first need to create tickets that in ticketing system, then some side effects are applied on those tickets. And after that, those already decorated tickets are sent to automation platform to be automated. So if that's down, we don't run any automations. We run the ones that are already running, but the new ones doesn't go through, and it's pretty bad. The second thing, if ticket proxy go down, then basically it's a total chaos. Like the whole customer support system is down. It's really not ideal. And lastly, this is your standard sort of distributed hodgepodge architecture, I would say. And a lot of side effects are on the same flow applied in different places, which makes it extremely difficult to maintain and extremely difficult to debug. It's also make it very difficult to understand what features actually exist in production and which features doesn't exist in production, because sometimes they're there, sometimes they're not there, who knows, you know? So it's really problematic. So the ticket proxy is that part which we really start thinking that is a big source of pain for us, and we need to do something about it. It was your typical state machine with so many other speakers basically are talking about. One fun fact, you know, if you have a really complex state machine, even the people who build it do not remember how it works. And it's like really problem, you know. So we actually had to go and we had to decode the entire service to figure out how it works before we could move it to Temporal, right? So it's really painful. But we did it, and we start improving resiliency here. Now, the actual workflow that actually is replacing this ticket proxy, the actual complete design is really gigantic. There are 3 workflows. We are using proxy workflows. We are signaling in between workflows. It's just too much for one slide and too much for one presentation. Maybe next time we can talk about it. I have simplified version of it right here. And the idea there is that we want to take the automation platform, but we want to stretch the beginning of the workflow all the way to the customer, all the way to the user. So when a user actually report an issue, it starts running a workflow. In that case, we can start doing much more better, we can start building and modeling much more better business process that is much more easy to understand, and we can be durable end to end, not just on one part of the system. And so this is basically a ticket proxy flow, which is spread it across the microservices. What we really want to do is to create a workflow. When you create your ticket or submit your request, your workflow start running. There is a query which allows you to basically check on ongoing status of your request from customer application. And at a certain point, we want to start creating tickets in the ticketing system. Now, what workflow needs to do is it needs to collect a lot of context about this ticket, like what booking it is, who is the customer, you know, what is the order, what are the items in the order, and things like that, in order to know what sort of compensation or what sort of resolution path to provide or to basically route it to. One big problem here is that we are still keeping our ticketing system, and the side effect baggage which the ticketing system does is pretty much like complicating things, because we want to be extremely decoupled from this ticketing system. So what we did is that we moved all the side effects to the workflow as well. So basically every single side effect that is decorating the workflow, that might be things like, for example, okay, which agent group should be solving this issue, etc., things like that. Things which pretty much were in the ticketing system before are now as a side effect in the workflow. So the workflow is absolutely self-sustaining and self-contained. After that, it doesn't matter if the ticketing system goes down, because we still have all information. We can run all the automated resolutions, and we just create tickets when the ticketing system recovers, right? So it's not really as problematic as it used to be before. One thing I really want to highlight about this is that if you model the entire flow end-to-end like this, as a set of several communicating workflows, what you are gaining is visibility. You understand, and everyone can easily understand, what is in production and what features are we supporting and what is it doing. And if there is any problem, you can very easily see what has happened. And the workflow is self-instrumenting. I mean, how crazy is that, right? Like, I don't know if you ever tried to instrument large microservice-oriented systems, but it's really painful. All the tracing, all the instrumenting is really painful. If anything goes wrong here, it's in temporal history. Just take temporal history and flash it to some data lake. We have all data we need. We don't need additional instrumentation at all. So in this new system, when we basically have a ticket creation workflow, which is a long-running workflow, we are now much more resilient to anything what possibly can happen in the production. Ticketing system is down, we're still up, we're still receiving requests, we're still automating them. We are just with certain delayed time creating the tickets in the system, yeah? There might be actual sort of agents who cannot do their work because they need to see the ticket, so those will be impacted, but less of the traffic will be fine. If the workflow goes down, still a little bit problem, but this depends, right? Because if just one workflow go down or just some of them go down, you're still okay. If the entire cluster go down, you would be pretty much in bigger mess. But in our experience, it doesn't really happen that much, probably until it happens. If worker goes down, we recover easily. We just reschedule the workflows reschedule workflow to different worker. Yeah, if everything goes down, it takes a little bit longer because before workers gets up. If temporal goes down, which by the way really didn't happen this year at all for our cluster, we at least don't lose any data. We don't lose consistency of the data. Everything will recover at that point when it finished, and we don't need to have a very heavy on-call duties when we are trying to manually dig through the databases and find out what went wrong and recover some customers, which is really painful exercise. All right, so in summary, we started with interesting, sort of like a non-usual use case, placed our system in our architecture at the spot when it made most sense. And we eventually sort of evolved to use long-running workflows and gain much higher confidence. Today, we are exploring or developing multiple ongoing use cases. One exciting one is chatbot on temporal, when we really take advantage of signals and queries and try to make even chatbot temporal workflow. This is actually very exciting. We actually make our stress testing framework, our stress testing tool for this, which allow us to stress test our throughput, our QPS of signals and queries. That's because Maru only does actions and it doesn't do signals and queries, and there are some different dynamic configuration which we actually have to do in order to maximize the throughput of signals and queries. So that was good. We are also building many other, or exploring many other use cases, subscriptions, offers, and campaigns, some sort of pipeline for machine learning training, etc. And the takeaways from this presentation. So number one, DSL totally works with temporal. That's like don't be afraid about using DSL if you feel that you want to build some sort of UI or some sort of DSL on top of the workflow. Second, start small and expand. So we started in a very particular area, and it took us a very long time before we start seeing and like basically adopting different use cases. So it's totally fine to start small and expand. And it's actually even better because you really gain confidence on the way about what's possible. And lastly, build complex topologies with workflows. it's funny how like the workflows start to be much more powerful if you combine them. If you like start to build much more complex topologies, and when you have a one system that is on workflows and another system that is on workflows, and they communicate together via workflows, it start to be very, very powerful tool and very fun way to design systems. So we call it in Grab, we call it workflow-oriented architecture. So from me, it's just let's go workflow-oriented, right? That's it. Thank you.